All right, ladies and gentlemen, welcome. Really want you guys to rewrite these on a separate sheet of paper so that you can have the practice down, okay? So take the time, pause it, write them down, and then as I go through them, it'd be smart for you to go through them as well. Now, I'm going to go ahead and write what each of these expressions means. That's what we're doing here. So 2 to the fourth power is actually 2 times 2 times 2 times 2. Don't really care what it is. I want you to know that this and this are virtually the same thing. Then negative 2 to the fourth power is actually negative 2 times negative 2 times negative 2 times negative 2. Okay? Then we go over here. Now this is a negative out in front. So it's negative out front, but then we have 2 times 2 times 2 times 2. Not the same thing. So let's go through these first three before we go any further, okay? So 2 to the fourth power, 2 times 2 times 2 times 2, that's 16. Now negative 2 times negative 2 times negative 2 times negative 2 is positive 16. You have an even number of negatives, so it's going to come out positive. Here we have a negative up front, and then 2 times 2 times 2 times 2 is 16, so this will be negative 16. Now, if you're using a calculator, be careful. If you're trying to see what negative 2 to the fourth power is, it is not the same as this. So make sure you are plugging it in correctly. Now 2 to the third power, that's 2 times 2 times 2. 1/2 to the fifth power is 1/2 times itself 5 times. I'm going to do this because I'm extra. Or what you could do is take each of these to the fifth power. So 1 to the fifth power and then 2 to the fifth power. So either way, you're going to end up with 1 over 32 if you wanted to know that. Then, next up, I have 2/3 to the third power, which is 2/3 times 2/3 times 2/3. That means 2 to the third power over 3 to the third power, which is 8/27, if you will. Okay, so that takes us through the warm-ups, if you will. And let's get into these properties now. These are properties that you're going to have to know. You don't have to have them memorized, but you're going to have to know how to use them. Super important here. So it'd be like 2 to the third times 2 to the fifth. Well, that's the same thing as 2 to the third, 3 plus 5, which would be 2 to the eighth power. So whenever you're multiplying two numbers with the same base, you can take the exponents and add them. That's the most important thing to know right there. If they have the same base, you can add the exponents. The reason for that is, if I have, like our example here, it'd be 2 times 2 times 2. That's this. And then I'd have 2 times 2 times 2 times 2 times 2. There are 1, 2, 3, 4, 5, 6, 7, 8 2's being multiplied. That's why there's an 8 there. Okay, now product of a power. Let's change it up and do 3 to the fourth, and then we'll do that squared. Okay, so that means this is a product of power of a power. We have an exponent on the outside of the parentheses here. This is the same thing as 3 to the fourth times 3 to the fourth. So we're squaring it. That would be 3 to the eighth, because 4 plus 4 is 8, or because 4 times 2 is 8. Either way, that would be 3 times 3 times 3 times 3. That's one of the 3 to the fourths. Then I'd have 3 times 3 times 3 times 3. That'd be the other 3 to the fourth. That way you have 8 of them going on right there. Then, power of a product. If you have two numbers being multiplied inside a parenthesis and we've taken that to the same power, that would be like, let's do 3x to the fifth power. All right? That's the same thing as saying 3 to the fifth, x to the fifth. So taking them both to that power. Another example, let me go ahead and put this over here real quick. Another example over this would be if I had 2 to the third, x to the fifth, that would end up being 2 to the third time. We have to multiply 3 and 5, so that'd be 15, and then x to the fifth. So this would end up being 2 to the 15th power, x to the fifth. The reason that 5 just goes on the x is because 1 times 5 is 5. Sorry if that was confusing. Let me go ahead and change colors. Now, this one's the tricky one right here. This is the one that you're going to have to really worry about, and I'm going to do several examples. If I have 2 to the negative first power, anytime you have a negative exponent, it goes to the other side. So what I mean by other side is, if you write 2 as a fraction, it's 2 over 1. So if I have 2 to the negative first power, that means that this 2 goes to the other side, which means it would go to the bottom. When it goes to the bottom, that exponent becomes positive. So 2 to the negative first power is another way of saying 1/2. Let me try that with 3 to the negative fourth power. That would be the same thing as 1 over 3 to the fourth. So another example, if I had x to the negative third power, this would be 1 over x to the third. If I have, and this is where you have to pay attention, please pay attention, 3x to the negative second. This is the same thing as, well, this is the only negative exponent. So x squared would come down here. The 3 stays up top, because that's technically 3 to the first. All right, so those will go into more depth during the notes, but I wanted you to have a little understanding of that before moving along. All right, so I'm going to go back to, let's do green, why not? So anything to the 0 power. So once again, if I have 4 divided by 4, do we agree that that's 1? Hope so. Now, that's where exponents come in as well. Like, these two work really well together. Matter of fact, I should probably do 6 first. Let me do 6 first. Quotient of powers. If I have x to the 7th over x to the 3rd, this is the same thing as x to the 4th, because 7 minus 3 is 4. So when you're dividing two numbers with the same base, we can subtract the exponents. Let me do a different example where it's easier to map out. X to the 4th over x squared. So what this technically is x times x times x times x. So 4x is up top, 2x is on bottom. Well, those go away and those go away. They make 1, and we're left with x squared there. So 4 minus 2 is 2. Not dividing, but subtracting the exponents. Now, with that being said, I'm going to go back up to number 5. 1 minus 1 is 0. So this is the same thing as saying 4 to the 0 power. Well, 4 to the 0 power is 1. You can use your calculator right now and type in a number, hit the caret button, hit 0, and it'll come back 1. It should. So if I have 5 to the 0 power, that's 1. If I have x to the 0 power, that's 1. So that's really all you have to worry about with anything with a 0 power. It basically turns into 1. And then we have power of a quotient, which I've kind of talked about a little bit before on the warm-ups, is whenever you have a fraction to a power, each of those gets taken to that power. So if I have, let's do 2/3, but I'll take that to the 4th power. That's the same thing as 2 to the 4th power over 3 to the 4th power. These both get taken to that power. If you want a more exciting example, x to the 3rd over 3 to the 4th power. Well, that would be, this is a power of a power right here. So I'm using, not that one. Using this one right here, number 2. This would be x to the 12th, because 3 times 4 is 12. And then this on the bottom would just be 3 to the 4th power. Now 3 to the 4th power is also 81, but you'll know that after working with it for a little bit longer. Okay. Let me get through some examples here real quickly and show you what we have. 3 to the 4th to the 2nd, this is a power of a power, so this is the same thing as saying 3 to the 4 times 2. This would be 3 to the 8th power. Might have been an example I just did. We have 5/8 to the 3rd power, which means this is 5 to the 3rd power over 8 to the 3rd power, which I'm a little rusty right now, but that's going to be 125 over, not 8 to the 3rd power. Probably 512. So 8 times 8 times 8. Okay. And then next, last but not least, they have the same base, and since we're multiplying, we add these. Conversely, over here, we multiply them since this is a power of a power. We're adding these. So this would be -2 and -3 plus 9 is 6. Now, you might be saying to yourself, but that's a negative exponent. Mr. Byrne, what are you doing? Well, a great question. Since it is a negative exponent, I can actually rewrite that as 1 over -2 to the 3rd, because that exponent will change to be positive down here. Now, since I'm multiplying, this is still being multiplied by -2 to the 9th, but if I want to write that as a fraction, that's over 1. So then if I multiply this, 1 times that is going to be that. And then if I have this times that, it's going to be this. So if we have this, we're dividing here. So that means we have to take these two exponents and subtract. What is 9 minus 3? It's 6. So either way you cut it, you get the same exact answer. I'll write this down here for those of you who aren't listening very well. 9 minus 3, we still get negative 2 to the 6th power. So fun example there. I like it. All right, now we're rewriting these, making sure they look nice. So we don't want negative exponents in our answer. So the a to the second is going to be there, but since this is a negative exponent, it's going to move up. So the a squared looks good where it is. The b to the negative third comes up here, and it becomes b to the third. Now, there's nothing left on bottom, so if you want to put a 1 there, you can, but you don't really need to. A squared b to the third is all you need to have. Now, we have a couple things going on in here. This is pretty interesting. So I'm going to rewrite this as negative 1, because that is negative 1, times y to the second to the 5th. And then times y to the second times, and this one has negative exponent, so I'm going to put 1 over y to the 12th. So a lot of things going on here. The first thing is each of these gets taken to the 5th power. So I'd have negative 1 to the 5th power, and then I'd have y to the, well, 2 times 5 is 10. And then this is still y to the second, and that's still going to be 1 over y to the 12th. Okay. Now, I'll deal with the negative 1 to the 5th in a second, but I'm going to deal with these two right now. So 10, y to the 10th times y to the second, we add those exponents. Since it's not a power of power, there would be 12y. So I'd have y to the 12th up top. I'm going to leave the negative 1 to the 5th up there, but then this would be on the bottom, y to the 12th. Now, 12 minus 12 over here, dealing with these exponents, I have to subtract them. What's 12 minus 12 is 0. So technically, you have negative 1 to the 5th, and then you have y to the 0. Well, what's y to the 0 power? It's 1. So then you have negative 1 to the 5th power times 1, which is just going to be negative 1 to the 5th power. Now, since negative 1 to the 5th power, or since 5 is a negative, or is an odd power, it's going to turn out to be just negative 1. So this whole thing right here, the answer is negative 1 when you simplify it. All right, let me get through these quickly. Let me see. Yeah, so I got 4 more problems to go. Here we go. I have rs squared over, this would be r to the third and then s to the negative third, because these are power of power, so they get multiplied. So I'm going to deal with my s. I'm going to bring this up here because it has a negative exponent. So I still have r, but then I'm going to have s to the 5th power, because when you bring this up here, it becomes s to the third, and then we add those two. It's still over r to the third. Now, this is where things get a little rough. That's r to the first, and that's r to the third. So technically, this is what we have. R, and then s to the 5th, over r times r times r. So those go away. R divided by r is 1. So what I'm left with is 1, 2 r's down here. So your answer is s to the 5th power over r squared. Now, another way to do that is taking r and then say, oh, well, it's 1 minus 3. So it'd be r to the negative second. Well, if it has a negative exponent, it has to go to the bottom. That's where it ended up. So that's why that is the correct answer there. Now over here, this would be 2x to the third, because 1 plus 2 is 3. And then a y over 4y to the third. Now we have a similar instance right here. We have y to the first and y to the third down there. One of them is going to go away. That one's going to go away, and it's going to take one of these with it. And 3 minus 1 is 2. So that becomes a 2. Now, 2 and 4, they're both divisible by 2. So that's simplifying a fraction. So what you really have here is x to the third over, that goes away, that becomes a 2, 2y squared. That's going to be your answer there. Kind of ugly, but, works. Now, the last two here, I'm going to try and get through these quickly because I'm already at 14 minutes. Ugh. So this will be 2 to the third, x to the 6th over 5 times 15 over 2. And then I'm going to bring these down here to get x to the 5th. All right, did a lot of steps there. Hopefully you're with me. 2 to the third power is 8, so I have 8x to the 6th over 5. And this still times 15 over 2x to the 5th. Now, at this point, you can do a couple different things. If you want to start simplifying, you can, but I'm not going to. I'm just going to go ahead and do my own thing here. 8 times 15 is 120. So I have 120x to the 6th, and that's all over
10x to the 5th, which worked out really nicely. So 120 divided by 10, that goes away, is 12. And then if I have x to the 6th over x to the 5th, 6 minus 5 is 1, so 12x is my answer. That's it. Now, number 9, tough problem here. We're taking it to the negative second power. We're taking everything to the negative second power. So you can do this a couple different ways. One, I'm just going to go ahead and take all these exponents and take them all to the negative second power. So since it's a power of a power, this will be x to the 3 times negative 2, y to the 2 times negative 2, 2 to the 1, since there's a 1 there, times negative 2, and then x to the 4 times negative 2. Now it's going to get ugly. I'm not going to lie to you. It's going to get real ugly, and we're going to have a lot of negative exponents, but we can handle it. Let me go ahead and change the color real quick. So now I have x to the negative 6th, y to the negative 4, 2 to the negative 2, and then I have x to the negative 8 power. Okay, now everything with a negative exponent has to move sides, so they all switch. It becomes this, 2 to the 2nd, x to the 8th, so both of these came up top, and then both of these go down here, x to the 6th, y to the 4th. Now there are 2 things I need to do. One of which is if I have 6 x's here and 8 there, 6 of them go away, and 2 are left up top. So I'll be left with x squared on top. Nothing changes the y to the 4th. It stays right there, and then 2 squared is 4. So that's going to be your answer there.